Welcome to the lecture. Topics to be covered in this video lecture, that is, we will see overview of creating the data science pipeline. Then we will see the different attributes of the bar chart and the box plot. Then we will see that how to read a text file, a CSV file and the Excel file. So this all is a part of the working with real data. So let's see creating a data science pipeline. So I have divided the data science pipeline into different parts like loading the data, preparing the data, EDA, that is the performing exploratory data analysis, learning from the data, or we can say training a model, and then comes the visualization. In loading the data, we have seen that how to read a file, how to read a CSV file, and how to read an Excel file. In preparing the data, we have seen the topics like introduction to descriptive statistics and the inferential statistics. In performing the exploratory data analysis, that is the EDA approach, in that we have seen the concept related to the descriptive statistics for the numerical data, then measuring the central tendency, that what is the mean, median and mode, what is the categorical data, how to understand the frequency related to the categorical and the quantitative data. Then we have seen the different data types and scales, that is the interval, ratio, nominal, ordinal. We have seen what is population and sample, what is percentile, decile and quartile. So all this we have seen as a part of the EDA. Then next we have seen training a model. In this we have seen the one machine learning model, that is the simple linear regression. For the simple linear regression, we have used the ordinary least square for estimating the parameters. For the implementation part, we have used scikit-learn and the states model for the linear regression. For the visualization, in the linear regression, we have used the scatter plot, and to plot a line, we have used that is plt.plot as the function. And we have seen the different charts like bar chart and the box plot. So this is what we have covered till now as a part of the data science pipeline. Now you call it as the data science pipeline or you call it as the data science life cycle. Both are very similar things, only the steps shown are somewhat different. But all the steps are very similar in both the cases. Over here, the total number of steps shown are 7. In the data science pipeline, the total number of steps shown are somewhat less than this 7. But it covers a very similar pattern in both the cases. So in the data science life cycle, if you say, then the first step is the business understanding. In that, what you have to do, that you have to collect the data that you are interested for. So suppose if I take an example of the linear regression, then over there we are interested to calculate the CO2 emissions. So I am interested in calculating the CO2 emissions. So for that I have to gather the data. So that gathering of the data is a part of the step 2, that is the data mining. So over here I have to gather and scrap the data that is necessary for the project. So if I want to calculate the CO2 emissions of the car, then I have to gather the data set related to the cars, in which it shows the different engines, that what are the features of the car, what is the engine used, and what is the CO2 emissions of the already manufactured car. Then comes the data cleaning. If there are some missing values in the data, then you have to clean the data. Then comes the data exploration. In the data exploration, it is very similar to the EDA approach in our data science pipeline. Then comes the feature engineering. It means whatever features you are interested for, that you have to extract from the data. So in the linear regression model, we have seen there are lots of columns in our data set, but we were interested in only 4 columns. So we have used only 4 columns from the whole data set. So this is what is called the feature engineering. So over here you have to select the important features and construct the meaningful ones from the raw data. So after feature engineering, you have to apply some machine learning model. So over here they have called it as the predictive modeling. So over here you have to train the machine learning model, and you have to evaluate their performance and use them to make some predictions. So in our machine learning algorithm, we have used the simple linear regression, and over there we have predicted the value of the CO2. And for the advertising data set, we are predicting the value of sales. Then comes the data visualization. In data visualization, we are visualizing the result by using the scatter plot, by using the bar charts, by using the box plots, or by using the simple linear regression line, that is PLT dot plot. After data visualization, again the first step is of the business understanding. So over here you have to verify that what the result you are getting and what you are looking for, whether both the things match or not. So you have to cross verify that. If you are looking for the CO2 emissions, but in the final result you are not getting the predictions related to the CO2 emissions, then your all data science methods is of no use. So over here after 7, the first step you have to again repeat it. Now next we will see in depth, that is the step 2, 3, 4 and 5. So step 2 is about the gathering the data. So we will see the different attributes related to the CSV Excel file and the, I can say, the text file, that is the notepad file if you want to read. There are various different other functions available to read the JSON file also, to read the data from the web also. But over here as of now we are covering this 3-1, that is the reading a text file, CSV file and the Excel file. Then for the data cleaning, you have to find the missing values and you have to treat the missing values. So for that we will be using this one, that is dealing with the missing data, finding missing data, and coding missingness and imputing the missing data. For the data exploration and the feature engineering part, we will be using this concept, that is the concept of data slicing, dicing, concatenating and transformation. So whether you want to select particular rows or columns from the data set, for that slicing is used. And for concatenating, it means if you want to join two different data sets, then for that purpose concatenation and transformation is used. Again, adding new rows and new columns, then sorting and shuffling, this all are the part of the data exploration and the feature engineering, you can see. But in this video lecture, we will see working with real data, and we will see the attributes related to the bar charts and the box plot. So let's start with it. So accessing data in a structured flat file form. So the first one is reading a text file. Reading a text file, it means my notepad file. So I want to read my text file and my file name is colors.txt. So let's see how my notepad file looks like. So in my notepad file, I have written the text like this, that is the color and its value. That is red is 1, orange is 2 and like that. Any type of text you can write in your notepad. So to read a notepad file, you have to write the code like this, that is with open. You want to open a notepad file, so you have to write the code like this, that is with open. As an argument, you have to pass the file name. My file name is colors.txt. Make sure that your file is in the same folder that you are saving this your IPYNB file. If your file and your notepad file both are not in the same folder, then what you have to do? You have to pass the whole path. Suppose my file is on the desktop, then you have to write like this, that is the C users, then desktop you have to write like this, desktop, and the file name like this, file name with extension. So over here you have to use the forward slash. If you are using the backward slash is like this, that is above the enter key, it is available in your keyboard. Over here the backward slash is not useful, you have to write the forward slash like this. If your file is in the same folder, then you can write like this directly. As in second argument, you have to pass that whether you want to read the file or whether you want to perform read and write both the operations. So over here, I want to only read the file. So I am writing R because I want to open the file in my read only mode. And whatever the file is, that will be saved in my variable, that is open underscore file. And I am printing the contents of the file. So I am writing statement, that is colors.txt content, and I am reading my file. So my whole file is saved in this variable, that is open underscore file, and I am writing open underscore file, that is my variable name dot, I am writing the read function. So it will read my file and it will show the content like this. Next comes reading a CSV file, that is the comma separated values file. So first of all, let's see that how the comma separated value files looks like. I have already provided you the tips data set. So if you want to download the tips data set, then you can write in Google like this, that is download tips data set. So you will get a link like this, that is the tips.csv, the GitHub link. When you click on this link, then it will show the file like this. So what is this file? This is my comma separated file. You can see over here my every value is separated by comma like this. So what you have to do, if you want to download this file, then just select all the contents of the file which is available on this web page. Just copy it, open the Excel, paste your content over here. So my all these contents are in the comma separated values. Now go to the data menu. Over there, go to the menu that is over here, that is text to columns. It is showing a dialog box over here. This is the delimited. Click this delimited, click on next. These values are separated by commas, so you have to click on the comma checkbox. Then you can see over here that my values which are separated by commas are now shown in the different columns. Now again click on next and click on finish like this. Then you can see that all your comma separated values are now shown in the table form. Now for saving the file, just go to the save option. Over here, just give the file name as tips, and from the save as type, you have to select this one, that is the CSV. Into the bracket, it is written as comma delimited, and just save this file. Suppose I am saving the file on the desktop, then you can save this file like this. So this is how you can save the any CSV data set which you can find from the internet. Now we will see how to read the CSV file. So for reading the CSV file, which function we are using? We are using the function like this, that is the pandas read underscore CSV, and into the bracket we are giving the file name that we want to read. Suppose I want to read the file name as tips.csv, then you have to write the file name like this, and suppose my object name is df. But over here you can see that I have used one another function, that is the pandas pd.io, that is the input output. I have used the keyword as parsers, and then I have written read underscore csv, and I am reading the file, that is my loan.csv file. So whatever my file is, my file gets read and it is stored in my object called loan. And I am printing only the age column from the loan data set, and that I am storing in my variable x, and I am printing the value of x. Then you can see that it is showing the output, and it shows only the output of my age column. Then you can see over here, this is my output. You can also read the file like this. You can also read the file like this. But this is the previous version, and this is the latest version, that how we are reading the file. But for the exam purpose, if in exam it is asked whether this is the valid syntax or not, then you should know that this is the valid syntax which is available in Python to read a CSV file. Now next is reading an Excel file. So over here, how to read an Excel file? We are using such type of function, that is pandas pd.read underscore Excel. But over here, I have used the another function. I have used over here, that is the function of the pandas only. So I am writing pd.excel file and I am writing my Excel file name. And I am storing in my object, that is XLS. My object name is XLS. And I am writing over here, that is xls.parse. I am using the parse as the function and I want to read the sheet 1 from the Excel. You all know that in Excel, there are various sheets available. This is my Excel file. You can see downwards that this is my sheet 1. After that, it is my sheet 2. So there are two sheets available and in both the sheets, I am having the data. So you want to read the data from which sheet? So for that, what you have to do? You have to write the sheet name like this. So I am writing the sheet name like this, that is the sheet 1. And I am writing whatever the null values are there in my data set, I am indicating it as the NA. So wherever the NA is written in my data set, so you have to treat it as the missing value. So this NA underscore value tells that. And I am printing the trigger values, that is I want only the values from the sheet 1, and if there is any NA written in the sheet, then you have to treat it as the missing value. Then you can see that over here I am reading my sheet 1, that is I am having the different columns. If I am writing over here, that is sheet 2, then you can see that my sheet 2 is showing in my output. So this is what my sheet 2 is. Now over here, suppose I am deleting one value. So randomly I am deleting, from the gender I am deleting 1 and from the age I am deleting 1. So randomly, suppose I am deleting 3 different values. I am saving this file and again I am running this code. Then you can see over here that it shows the value as NaN. NaN, it shows the values from where I have deleted the values from the cell. It means what? That are my missing values. So that missing values is shown as NaN in our Python. So this is what the NaN is. Now suppose instead of space, that is the blank value, if I am writing the question mark over here, instead of missing values, I am writing over here like this, that is the question mark. Now I want to tell the Python that wherever the question mark is, it means it is my missing value. So let's see what the Python is doing. The Python is just printing the question mark. It is not treating it as the missing value. It is treating it as one of the character. Now I want to tell that wherever the question mark is, that question mark, it means the missing value in my data set. So I'm writing NA underscore values equals to question mark like this, and I'm running this code. Then you can see that now it shows NaN. So wherever the question mark is, it is treating it as the missing value and it shows the value as NaN. So NaN means missing values in the Python. How to treat this missing value, that we will see in our future video lectures. Now, what if you want to perform this sheet 1 and sheet 2 and this NA underscore values type of attributes into your this function, that is the read underscore Excel. So we have documentation for that. So let's see. So this is my website, that is the pandas.pydata.org. This is my official documentation of this read underscore Excel function. So when I am writing read underscore Excel, it has different attributes like this. So these are the so many attributes available in the read underscore Excel. So if you want to read the particular sheet from your Excel, then you have to write the attribute, that is sheet underscore name equals to, and then you have to provide the sheet name. So let's do it over here, that is the sheet underscore name. So how to write the attribute? You have to write the attribute by specifying a comma, and my attribute name is sheet underscore name equals to, and my value is, suppose I want to read the sheet 2. Then see, this is the output from my sheet 2. Now let's see about the NA underscore values. So whether it is available in this or not. It is available over here, that is NA underscore value equals to none. By default, the value is none. If you are specifying any character, then it will treat it as the missing value. So whatever the attributes are over here, its description is given over here like this. So it is not necessary that always you have to use all these attributes. It depends on your requirement. Now let's see the next one, that is the attributes of the bar chart and the box plot. So over here I am not reading any data set. I am just writing the value of x, that is my value of x. It is represented as a list, that is 0 1 2 3 4 5, and my y values are like this, and I am creating a bar chart, and in my bar chart I am writing the values. So let's copy this into my new cell, and I am writing that is plt dot bar, and I am simply printing the bar chart values, that is the x and y. So let's load the file. So I have loaded my file, that is my matplot.pyplot library, and I'm writing plt.bar. So this is my x values, that is 4 0 1 2 3 4 5. I have my different y values, that is 5 8 9 10 4 7. So the value for value 0 on the x-axis, I have the value 5 on the y-axis. That is for value 0 on the x-axis, I have value 5 on the y-axis. So like this my bar chart is plotted. Now next is I want to mention the colors. So for that I am writing the colors variable like this, and I am giving a list. In list I am saving the different characters like B, R and all other as B. Now what is this B, R and all other as B? So let's see. This is my character and my corresponding colors. So character B means it is my blue color, G means green color, R means red color. So over here we have used blue and red. So I want all the bars as blue, but my second bar as the red. So for that I have to mention the color as an attribute. So I am writing over here that is color equals to, and my variable name. My variable name is colors, that is over here. This is my attribute name, this is my value name. And I am running this code, then you can see that my second bar gets red like this and all other are blue. If you want last one as green, then you can write G over here. So it depends on the character that you have used according to the color. Now by default the width of all the bar charts are same. But if you want to change the width of the bar chart, so it is just for the better visualization purpose. So you can write like this. Suppose I am writing the width like this, that is my width as the variable, and I am mentioning the different value as 0.7. All the values are as 0.7 and my one value is of 0.8. So for that I have to use the attribute, that is width as the attribute, and the value I am giving this variable name, that is as widths. Then you can see over here when I am running this code, then this bar is somewhat thicker in width compared to my other bars. Now next is my box plot. So in the box plot we will see some of the attributes related to the box plot. So over here I am not reading any data set. I have generated my different values. I am creating my data by using the random function from the NumPy library. So I am writing np.random.rand. So this function we will see in our MSc2, but just for now focus on this, that is my box plot part. So over here I am running this particular code. So this is my box plot. Then you can see this box plot is slightly different from the box plot that we have seen. So where my median is, over there it is showing me the triangle like this, that is triangle on both the side. So that you can do with the help of this notch attribute. So what this attribute will do, you can see over here, this is my documentation of the boxplot function, and it shows notch, that is the notch as the attribute name, and it as the value, it accepts the value as the boolean value, either the true or false. So what it will do, If the value is false, then it will plot a rectangular box plot. So you can see over here, if the value is false, then it will show a rectangular box plot. If the value is true, then it will show a box plot like this. That is, on the median, it shows the triangle like this. These are the different outliers. By default, the outliers are there. And for mentioning the symbol of the outliers, you have to use the attributes, that is the SYM. You can see the SYM attribute over here. So the default symbol for the flyer point, it shows. So for the default symbol of the flyer points are the B plus. So this are my plus symbol, it means it is my outliers. If I mention over here that is my X like this, then you can see my outliers are shown with the help of the symbol that is X. If I write over here that is O and I am running this code, then you can see my outliers are shown with the circle as the symbol. So there are various attributes available in the box plot like this. So again, it depends on your requirement that what type of box plot you want. So we have seen some of the attributes, that is the two attributes from the box plot and two attributes from the bar chart. So this is all about for this today's video session. So thank you all.